Okay, this week our unit is 8 rational functions, and we are beginning with inverse variation. So I'm going to skip around in the notes, highlighting the important parts. For the rest, you can come into tutorials or you can get the notes from a friend. So the first example I want to do, or the part of the notes that I want to do, is the general descriptions of direct and inverse variation. So for direct variation, it is a linear equation of the form y equals ax, where y is said to vary directly with x. So it's like y equals mx plus b that we're used to, slope-intercept form, y equals mx plus b. But here, the slope is the a value. So here, the m is a. So a. And the y-intercept, which is the plus b, is going to be 0. So the y-intercept has to be 0 for these direct variation equations. So we're looking at the linear equations y equals ax plus 0. So these are all linear functions, all lines that go through the origin. So they have to go through 0, 0 in order for them to be direct variation. On the tables, we saw from the previous examples that as x increases, y also increases. Same thing the other way. If x decreases, y also decreases. And in order for us to tell for sure that it's direct, then the y divided by the x needs to be a constant number. So if it's direct, that will happen with the tables. For the inverse, the opposite thing happens. So as x increases, the y value is going to decrease, or vice versa, as x decreases, y can increase. But in order for us to tell for sure that it's inverse, you have to multiply the y by the x, and that number needs to be constant. So y times x is a constant number. So if that happens, then it's a rational function. A rational just means fraction of the form y equals a divided by x. So here's the general form for inverse, where y is said to vary inversely with x. So inversely with x. So here, the a value, again, is the constant that you get. So over here, when you multiply them together, you should get the constant value of a, and that constant is called the constant of variation. These graphs are all the ones that have curves, all the curves that have the x and the y axes as asymptotes. So here, this part's never going to cross the x-axis, so there's an asymptote there, and this part's never going to cross the x-axis or the y-axis. So 2 asymptotes. This graph actually has 2 sides to it, but when we deal with variation, we're only looking at the positive side of the graph most of the time. All right, so a couple of examples are the equations and the tables. So for the equations, we're looking to see whether it looks like a linear function with the y-intercept of 0, or a rational function with a number divided by x. So looking at number 7, in order for us to tell, we have to get y by itself. So for a, we have to multiply both sides by the 9. In multiplying both sides by 9, we get y equals 9x. And since this is y equals a number times x, we say this has direct variation. So y varies directly with x. So just direct. And then for part B, again, getting y by itself, we need to divide both sides by x, divide by x. So we get y equals 3 over x, which a number divided by x without anything added is called inverse. And then finally for C, if we look at C, the coefficient of the x is 1. So this is like y equals ax. However, this little plus 3 that's there means does not have a y-intercept of 0. So this plus 3 makes it a neither variation. In order for it to be inverse or direct, it has to be centered at the origin. Okay, so what I'm going to do here is I'm going to create a D, because there's another one that we tend to have trouble with, which is 4y equals x. So here, in getting y by itself, we would divide it by 4. So when we divide both by 4, we have the equation y equals x over 4. However, the actual number that we're dividing by 4, the coefficient of the x is 1. So instead of thinking of it as x over 4, we can think of it as 1/4 times x. And this is a y equals a number times x equation. So this one actually is a direct variation. So just because we see this as a fraction, x over 4, doesn't automatically make it inverse. If x is in the numerator, it's multiplying by a fraction. So you need to make sure you double check that part. Just because it's a fraction doesn't automatically make it inverse. All right, and then looking at the tables, so we have to decide, is it an increasing or increasing-decreasing relationship? And then we can classify it as direct, inverse, or neither. So if we look at the x's here, these x's are increasing as we move down the table. And then here, these x's are decreasing. So it could be, since it has the opposite relationship, it could be inverse, but it doesn't have to be if the variation part doesn't come out to be constant. So here we want to do, so it could be inverse, but then it also could be neither if it doesn't work out to be a constant product. So in order for us to tell for sure, for inverse, we multiply the x's to see if this is a constant number. So right here, 3 times 16. 16 times 3 is 48. And then we just have to check with all of them. 8 times 6, 48. And 2 times 24 is 48. So since these are all the same, then yes, we can say it's inverse. And we can actually write the equation. This is your a value. So it would be y equals 48 over x. Now looking at B, as x's increase, so here the x's are increasing, the y's are also increasing. So increasing means it could be direct, but once again, it doesn't have to be. It could also be neither in this case. So we have to tell for direct, we divide the y by the x. So we take the 9 and divide it by 2. And that's 4.5. And then we take 36 and divide it by 8. And we got to check, make sure it's 4.5. And then the last one, 72 divided by 16, is also 4.5. So again, this gives you your a value. So in writing your equation, since it is direct, since it's a constant quotient here, you can write this as y equals 4.5x. Since it's a linear equation, and because they're the same, that means it's centered at the origin. All right, the final one, looking at the x's, those are increasing. If we look at the y's, those are also increasing. So increasing and decreasing means it could be direct, but then it could also be neither if it doesn't end up having a constant quotient. So here, if we divide 5 by 2, 5 divided by 2 is 2.5. And then if we do 9 divided by 4, we get 2.25. So right there, we see that it's not a constant quotient. So this tells us that it's going to be neither.